So let's just recall the exponent law that you started in grade 9 and then, of course, touched on in grade 10 as well. Okay, so when we multiply two numbers that are the same, so see the base of x and x, what we do is we take the exponents m and n and we add them. Okay, and when we divide, and again, it has to be the same base. So here the same base is x and x. So we take the exponent m and we subtract the n. And it always has to be the numerator subtracting the denominator, and that will be the new exponent. Okay, and now let's review the distributive property. So I have 4b, and we have to distribute it into the bracket, b cubed minus 2b squared minus 4b plus 5. Okay, so 4b times b cubed is 4b squared. All right, let's see if this blows up. Yeah, this is better. Okay, 4b times -2, so 4 times -2 is -8, and then b times b squared is b cubed. Okay, 4b times -4b would be -16b squared, and then 4b times +5 is +20b. So there's a little bit of a review of distributive property. Now, when we're expanding binomials, we can use an area model. So what we would do is, for this question, we're expanding 2x plus 1, and we're multiplying it by 4x, or sorry, x plus 4, and sorry, 2x and then plus 1. And then we would write x plus 4 down the side. And what we want to do is we want to multiply each of these together. So we have x times 2x, which is 2x squared, x times 1, which is just x, 4 times 2x, which is just 8x, and 4 times 1, which is 4. And what this allows us to do is it allows us to multiply and not forget to expand any of these terms. So what we have here is 2x squared plus x plus 8x plus 4. And then we just want to collect those like terms, and we're left with 2x squared plus 9x plus 4. Okay, how does it look with 3x squared? So we can do 3x squared minus 2, and then we have x plus 5x, and then you can put a +5 here. Okay, so 3x squared times x is 3x cubed. X times -2, it's easy, -2x. 5 times 3x squared is 15x squared, and 5 times -2 is -10. And we can just simply, on the side, let's go blue again, we can just take all of these numbers that were multiplied and we can put them on the side. So 3x cubed plus 15x squared minus 2x minus 10. And what I did there was I put this x squared before the x, and I just skipped that step by rearranging these in my head so that I didn't have to rearrange them later, because now they're in order. Okay, so now we're going to actually expand these using like a distributive property. So this is binomial expansion. It's like a binomial multiplied by a binomial. So we take this x term right here, and what we want to do is we want to multiply it by every single term in the second bracket. So we start x times x squared, and you take that x and you keep going. X times 3 is 3x. And there's nothing else in that bracket, so now we're done. Okay, now 2 times x is 2x, and then 2 times 3 is 6. And then all we do is collect like terms, and we're done. Okay, so you can do it with the area model, or you can do it with the, I call this rainbows because they look like rainbows. So beautiful. Okay, either way, and you're going to come up with the right answer, and either way is a really good technique. So, example 5. Find the expression for the area of a rectangle. So this would be the rectangle, and the length would be 2x minus 7, and the width would be 4x plus 1. We know that the area is just the length times the width. So we have area equals LW. Okay, and we know that we have a length right here of 2x minus 7. And we know we have a width of 4x plus 1. Now, we want to find an expression. So this is our factored form of the expression, but in a question like this, because we're trying to expand, we're going to find the expanded expression. So let's do 2x times 4x and then 2x times 1. So we get 8x squared plus 2x. Now, negative 7 times 4 is negative 28x, and negative 7 times 1. Okay, so this right here is the expression for the area of the rectangle with this length and this width. And just be comfortable having an expression without having an actual value. So it's not asking what is the area, it's just asking what is the expression for the area. And the area is going to change every time depending on what that x value is.